So please give a warm ShmooCon welcome to Jay Beale, who will be talking about escalating privileges with Kubernetes.
Hey everybody. Wow, this is it's really good to be back. I've got a couple mics here, and I'm hoping the levels are good and I don't feedback on you. Cool. Well, I'm here to do a Kubernetes talk, and I'll be showing you something I found that is some zero-day, and I'll be showing you some other fun stuff. So I'll just jump right into it. So first, I have a bio slide, but nobody ever reads these. They're just seas of text. You could never kind of get through it. So I decided to make a different kind of bio slide, and I hope this catches on. So like Kaz said, the book that he and I, or one of the books we wrote together is up in the corner, but there's more recent stuff like my child on here. Anyway, so this is my bio. I work at Guardians, and this is a really special ShmooCon for us. We started coming to ShmooCon early on. Before we hit that point where you couldn't buy enough tickets, we would just bring the whole company to ShmooCon and make it our all hands. So for us, this is our 20th anniversary, and it's homecoming. So thank you all for saying hi. I've actually seen some of you wearing t-shirts of ours from years back, and it made us all really happy. We took pictures and everything. Without that much further ado, what are we gonna see? So what I'm gonna do is talk to you about what happens when you take a Kubernetes cluster and put it on a cloud provider. The one in question today is gonna be AWS. I'm not picking on AWS because all of the cloud providers will have this same kind of problem to solve, and they've done some cool work solving it, but you have to know kind of where the weaknesses are, how much you can, what you can trust it with, and what you have to do, what your part is, what your responsibility is to make things safer. So we're going to go through and basically talk a little bit about Kubernetes and AWS, and then I'm going to do some demos. We're going to attack three of the systems that we use to make things make it so that cloud workloads can do things and have some authentication and privilege. But do that a little more safely. And that's really hard to talk about generally, but don't worry, we're going to get super into it. Also, I really enjoyed Mark Manning's 2020 ShmooCon talk. He did some really good Kubernetes stuff. If this is the first Kubernetes talk you're seeing at Shmoo, you should go watch his. I'll wait. Okay, cool. So a quick little intro. I can't tell you all of what Kubernetes is, so I will give you the barest minimum of what I can in background. So real quick, I think what we know is Kubernetes is something where it orchestrates work, it orchestrates programs that are going to run on computers in containers. So we call it we basically say maybe it's a software-defined data center via container orchestration. But very confusingly, you will come to a talk like this, and you've said, I'm ready to hear about containers, and we'll keep talking about these things called pods, and that will be very confusing for a while, and don't worry, it gets easier. But short version, what you're seeing here are a bunch of pods. Pods are the smallest unit of compute. They have a container in them. Sometimes they have a volume in them. They often have a volume in them. We'll talk about volumes a little bit when we're going through some of this today. But containers are in pods. Pods are on nodes. For the rest of the hour, whenever you see a six-sided shape, that means you're looking at a computer. And that computer is a virtual machine or a physical machine. In AWS, it's going to be a virtual machine. And we're going to call it a node, or we're going to call it a virtual machine, or we're going to call it an instance. I'm going to try to say node over and over just to keep it really simple. The nodes are the things that have the pods on them. Now, this is a weird one, but a node is a Linux, well, for us right now, a node is going to be a Linux machine. Containers are just, containerized programs are just a bunch of programs running on a Linux machine, and Linux kernel's keeping track of, is doing some note taking and being okay, this one can only see this part of the file system. That's there's whole really cool talks on how little a container is and kind of what it is, but it's cool. So anyway, our issue is that we're going to have, so that's our kind of like simple background for Kubernetes at large. If you came for an introduction, I have thoroughly failed you. But we're going to do fun stuff. So Kubernetes clusters are basically there to run programs. So we can talk about programs, or we can talk about programs running in containers, we can talk about processes on Linux machines, but the simple way to abstract it is to say it's a workload. So if I say a workload, I'm generally kind of mean a program running in a container, or I mean a container. So we'll say workload, it's kind of what the cloud folks talk about, partly so that they can, like in one breath, talk about something where you've got a virtual machine, or where you've got a container running in a Kubernetes cluster, or you've got something that's serverless. It's a workload. So what's running in those containers, in those pods, on the clusters are workloads, they're programs that have to do things. And if they're in a cloud environment, they're probably, some number of them, are probably going to be using cloud services. They're probably going to be using the APIs that Amazon holds. I mean, I think, what does Amazon have, like 30, 40, 100, stop me when I get too high, different products. So all of these different things, whether it's like those S3 for storing things, or ECR for holding your container images or whatever, all of those different APIs you basically have to authenticate to most of the time. So then you say, okay, well, that's fine, but these programs that are in the containers, it's okay, I'll just give them all a credential, right? I'll give them a long-lived credential. I'm sure there's some way to cycle them. That'll be fine. You'd be like, well, how will you do that? You could put it in the container image, but we've all heard not to do that because, well, the container image is going to get used in multiple environments, and maybe it's going to get used by other people, and all kinds of bad juju. So we don't do that. What we do instead with Kubernetes or with cloud in general is we kind of like push configuration in, or we let things pull configuration in, but it's kind of dynamic like that. So one of the biggest ways that this happens, that this works out, is you have a container that's running in a cluster on a cloud provider, and it basically reaches out to this thing called the metadata API, which we'll see in an image in a sec, and says, hey, could you please tell me what my AWS IAM role is, and give me a credential for it, give me a short-lived token that I can use? It's like, yeah, sure. So just backing up for a second, the way this worked before we had containers running in machines was this service. This, like, I'll give you your credentials if you just query the right point on the network. This was done at the level of a computer. So those nodes, those virtual machines on which we have our containers, each node gets one AWS IAM role, and it just gets one. So that's fine. You're running a virtual machine, you got a program on that virtual machine. It's not like the 90s. We don't put 15 different kinds of programs on a virtual machine normally. We have a virtual machine sized the right way. It's elastic, boogie, woogie, woogie. And that virtual machine pulls down its credentials, and it does the things. It has what level of authorization it needs. But that's not very granular when you say, actually want to take that virtual machine and chop it up and put 15 different programs on it and have them each be in their own container. And that's what we're going to talk about today, is technologies that do that and then kind of break them. So, okay, so what does this look like? Here's how that works, and here's how that works. Remember, anytime you see the six-sided thing, somebody remind me whether that's a hexagon or an octagon. I think it's a hexagon. Hexagon? Okay, whenever we see our hexagon, that's a node. A node's a virtual machine. Okay, so we got a process. It's running on the hexagon. It's running on the node. And that process basically will reach out to the metadata API, this magic IP address, 169.254, 169.254, and say, hi, could I please have my security credentials? And we'll get back like, yeah, here is your role is the node instance role. And it will let you do things. And you're like, thank you. And now you can reach out to S3 and go and read that Darkhold bucket. Cool. So that's how it works before we go containers. When we go containers, we can keep doing this, but if we don't do anything, if you start up an EKS cluster right now, right, or you start up your own self-managed cluster on Amazon and you want to do this, For any given node, for a node, all of the containers on there basically are sharing the same account. That's what you get right now if you stand up the latest EKS immediately. So all of those containers are all reaching out. They're getting the same node instance. And what that means is that you've got to put all of the things that a node might need is going to have to go in the same place. And I've got some diagrams for this. I'm going to stop and say, by the way, you might start noticing I say Darkhold and I say Wanda a bunch and I say America Chavez, and this is all themed on a recent Doctor Strange movie. So if you haven't seen it, I won't wreck it, but you'll at least get the themes. So Wanda Maximoff is going to be our kind of bad person. We're basically playing her because we're the attackers, and Wanda wants to get America Chavez's powers so that she can move from universes. Okay, so when we do this, what happens? I've got Doctor Strange and I've got Maximoff. These are each containers. Whenever you see a circle or an oval on our hexagon, on our node, it's going to be containers. So you've got Doctor Strange, you've got Wanda Maximoff. They're both running on the same node. They need to reach out to the metadata API, get their credentials, and then Doctor Strange needs to be able to read this 1S3 bucket called Darkhold. Evil, powerful book. And Wanda Maximoff needs to be able to, say, do some EC2 stuff, make snapshots of instances, volumes, and start up clone ones, take them over, and in general be batty. But if they're both going to run on the same node, they're both going to have containers on the same node, they're both going to get that node instance role, the exact same thing, node instance role, and as a result, they're both going to have powers that they shouldn't. Wanda will have Doctor Strange's powers, Doctor Strange will have Wanda Maximoff's powers. So the solution to that is what's going to come up next, and then we're going to poke holes in it. So this kind of thing, the way we solve this is with something that kind of gets generally called workload identity. So workload identity is going to help solve this, but this is my visualization. We have all these pods. We have 6 different pods here. They all have different things they need to do. One of them needs to read a given bucket. Another one needs to read a different bucket. Another one writes the buckets. Another one sends SMS spam. Another one creates load balancers and so on. So if we don't add workload identity, the only way to let them all have their credentials via this metadata API thing is that they're all going to have the same node role that's going to be seriously, over provisioned. So what was the first solution? The first solution, classic, still in use, is called Kube2IM. And what it does is it proxies requests to the metadata API. And I'll show you this on a picture in a second. And what it's going to do, I'm telling you, all of this is just Linux. So what it's going to do is basically programs on your system are going to reach out to that 169.254 address, and Kube2IM is going to write an IP tables rule that says, let's NAT that back to me, and it's basically going to run that proxy. And for all the things that aren't getting credentials, it'll just proxy it on. For the things that are getting credentials, it'll do what it does. And what it does is Kube2IM will be the one thing on the node that has the nodes account. And it will, and this will happen on all of the nodes where you have evil containers going. Oh yeah, remember, I think all of my users are attackers. I think all of my workloads are either hacked or intended to hack me. It's occupational hazard. So anyway, Kube2IM is going to intercept all those requests. It's going to be able to, it's going to look at the pod's definition and say, I see that you're supposed to have AWS role this. And it will do this kind of, it'll use the security token service to assume whatever role that pod should get. It'll get short-lived credentials and pass it on. That all seems better on a diagram. So this diagram's not as complex as one of the future ones will be, and I apologize for that a little. So anyway, now we've got Strange doing the stuff in green, Maximoff doing the stuff in red. They're both doing the same thing. They're both hitting the metadata API. They both are trying to hit the metadata API. What's happening is instead they're kind of being redirected. So this is the goal, is they end up getting separate roles. Strange gets a role called Reads Darkhold, and Wanda gets a role called Clones Worlds. So what we're doing in this talk is assuming node compromise. So things get it's really weird, beginning, everyone was like, wait, you're talking about Kubernetes and you all are always talking about being inside the thing. You're like, well, it's kind of not that interesting from the outside. There's not a lot of attack surface. And when you're inside, there's a lot more, but the really juicy and challenging part is what happens if you get container breakout one way or another. We'll talk about the different ways. So one of the ways you can get container breakout is just somehow you were able to stage an overly privileged container. The defaults will totally let you do that. Ian Coldwater and Duffy Cooley have a nice little one-liner. If you are allowed to create pods and no one's done anything to change the defaults, then you can create a privileged pod and you can take over the node. So it's not that strange. It's not that odd. The other one, though, is there's constantly, there are Linux kernel vulnerabilities all the time. What makes a program something that's in a container is just Linux kernel keeping track of its view of the file system, its view of the network, its view of et cetera. So if you have a kernel vulnerability, there's a very decent chance that somebody can turn that into, let's change those tables. So we'll wave our hands and say the container breakout is not just theoretical. So if you've gotten control of a node, whether that by having an overprivileged container, by having container breakout, or any other way, if you've compromised the node, you have the node's privileges, and those node's privileges are kind of like any control plane elements that are on the node that have to have some privileges to do their job. There's whole great talks on that. Again, see some of the ones that I'll reference. Kubernetes has been trying decently hard to make it so that whatever control plane elements are on each node only have what little privilege they should have. So an example is the kubelet that's running on a node. It's told what pods to create. It then goes and tells the container runtime to create containers, and it gives them configuration, and so on. And when it does that, it's got to push in configuration. It's got to push in things. It's got to push in secrets, and so it's got to be able to read all these secrets. But the goal is, the idea is, the design principle is, the kubelet on a node should only be able to read the secrets that are for its workloads, for whatever stage to that node. So that's the expectation that we all have, and that's an expectation that's not going to hold up with some of this workload identity stuff that we're doing today. There was a great talk a couple of years ago called Walls Within Walls, What If Your Attacker Knows Parkour, that kind of talked about some of the ways that people were trying, that researchers were getting around that, and then how they fixed it. It's a great reference. So we're going to use, for what we're doing, we're basically going to take a Wanda Maximoff pod, and this pod will probably be like this most of the time. It'll just be something that is able to mount a host path volume. Now, some of you know about host path volumes, and you're like, lame, Jay. Come talk to me after about how the new pod security standards do block, like in the thing that's supposed to block all known privilege escalations, the middle one, there's like pod security standards. There are now 3 things. You either get you do it by namespace, you either get no protection, you get complete, but it's a little painful, so you have to be really mature, or you get the thing that, don't worry, it's good enough, it blocks all known privilege escalations, and it missed one. It missed it missed persistent volume claims, which were in Kubernetes' first third-party audit. So I don't know how that happened, but maybe it was for backwards compatibility or something. But this is actually reasonable. I use the host path volume instead of doing the PVC because it makes it a little easier to follow. What I want to do is do a first demo and basically say if we can compromise one node, then we get, remember I said, if you compromise a node, you should get the ability to read the secrets for any workload that's put on that. You should only get what privileges you need for that node. We should be able to have a compromise of one node without losing the whole cluster, without losing either control of the cluster, control plane, or without losing, honestly, whatever the cluster was there for. And in Guardians, we've done a bunch of pen tests, and our experience has been, if we're on a cloud provider, very often, even if we can't control the cluster, the kinds of things I'm about to show you end up making it so that you end up getting everything you wanted. It's like the whole thing we're on a Windows environment. if you don't get DA, but you do get every bit of contents the file shares in the databases, you have all the data, who cares? So let's do our demo. So what I've done here is just done a quick thing to show you what happens when you're in a pod. So this pod's called Dr. Strange. When Dr. Strange says, hey, give me my identity, I'd like to know who I am. Oh, apparently I need to switch what is shared. That's not good. How do we do that? Let's kill that and go there. Did that do it? No. Well, that's very bad. And I am in that mode where you're like half as smart as you normally are, because there are a whole bunch of people looking at you and hoping that you'll, use their time in a way that doesn't, that's considerate. So there we go. Okay, so here we are. We're going to start out. We're in one pod. If we're in a pod, this is a cluster that's running kube2im. If we're in a pod, in a cluster, in AWS, and they're using our first workload identity product, kube2im, an open source project, if you're in Dr. Strange's pod and you reach out and ask the metadata API for your role, that is if you just run some AWS commands, what you get back is, hey, you have the protect timestone role, not the node's role. Good, that sounds great.
Can you make the font bigger?
I can't. The question was, could I make the font bigger? And the answer is, no, I have apparently potentially screwed you. That sucks. I hate when people do that. I will narrate a bit. What's scary is he's in the second row, so I've really screwed up. So anyway, what I've done is then put us in another pod. I put us in that overprivileged pod, in that Wanda Maximoff pod where we're going to mount the file system of the node. So in mounting the file system, then I just ran a chroot command so that everything will feel like I'm just in that file system and not in the containers file system for a little bit, because that'll make it easier for me to go and explore the file system and so on. So what I'm going to do, this is a container that actually has, it's running, it's got that file system. It's also sharing the host's network interface. So it's kind of like that part of the containerization has been broken. I haven't gone as far as just saying, I have access to the file system, let me set up a cron job, which is something we do in Kubernetes. We're like, we have access to the file system, we'll set up a cron job, have something reach out to our C2, cool, we're outside all the containment. So I've just, the kubelet is allowed to get a list of pods and get all the detail about the pods. We're going to use that a few times today. And so what I've done from Wanda Maximoff's perspective is I've said, give me a list of the pods, and then I've said, give me all the detail, all the status detail about the pods. Nothing secret, but all the status detail about the pods. And it tells me all of the all the AWS IAM roles that are in use. So cool, I see some. Remember, Wanda wants to travel the multiverse. She wants America Chavez has power to travel the multiverse. And so what we're going to do is try to get that capability. So I've taken that list of roles. We're calling them ARNs. I put them in an ARN file. And then I'm just running a quick loop that says, hey, let's do a hit the STS security token service and ask if I can assume each of the roles. And because we've got that, because we've broken out, we're able to assume every role that is in use. We're able to assume every role that's in use that node might have to use. And by default, the way every cluster I've seen is set up is that no one is really doing the extra work, and it's actually a pain in the butt, because part of what you wanted out of Kubernetes was to be able to really flexibly use all the compute and not have to spend more. So people will make it so that every node has the ability to assume every role that could be used anywhere on the cluster. And so what I'm showing you is kind of a quick manual example of something that some of my coworkers automated. And so what I've done is just said, let's go and do an STS to every single role. And we can just see that going by, and that kind of gives you a sense for you can do a lot. So as soon as we're outside the container, we have probably all the roles in the cluster, but at least all the roles that could be used on this node. Not even the ones that are being used, but the ones that could be used. It's fairly weak. We're going to take one example. This is a shorter demo, and we're going to say, hey, let's take that America Chavez, the role that the America Chavez one had, the travel the multiverse. We'll ask for it. We get those credentials, and if I take those credentials and use them, just export my AWS environment variables, then when I run get caller identity again, it says, you have that role. You are doing things as that role. And whereas Wanda Maximoff couldn't list any of the S3 buckets, this other account can, this other role can. And so Wanda has gotten the ability to see all the S3 buckets, and actually America Chavez is so provisioned that Wanda will go and just delete one too, because she kills people, so she just took out a universe. Hope you didn't, or at least the Kamar Taj, hope you didn't level those wizards. So this is kind of this is the simple one. This part, I would say, is not new. I think that lots of people have got to know about this. So that's the kube2im, and the reason, so I've just kind of show you the implementation, like why that is. So the way it works, remember, if the strange container or pod tries to reach out and get to the AWS Meta API, it gets redirected to a kube2im proxy program, which has set up via IP tables. That's our steps 1 and 2. And then step 3, kube2im actually makes the query, actually goes and asks the Kubernetes API server, tell me about this pod, what role should it have? It's just an annotation, it's listed. I'm not going to get into kind of like without namespace isolation. It's like if you can create a pod, you can have all the service counts you want. You can have all the, it's really bad. So anyway, you get back, the API server tells kube2im, yeah, that pod's supposed to have reads Darkhold. And so kube2im asks the STS service for a token for that role and gives that token back to Strange, and Strange can do Strange's things. So that gets us, without the container breakout, without the overprivileged stuff, that actually does make it so each of the containers gets a role and not all of the roles. But if you break out of the container, this one's trivial. And the way that I got to have some experience with this, I didn't get to have a direct experience with it. I got to watch some of my coworkers who were in our front row. We have Rob Curtin-Seifert and Jareth Kelly, and they actually were on this big test. And like I said, you have lots of things in the cluster. So this was a big product, and the company was running the product in Kubernetes. They had like 50 different roles, and those 50 different roles could do lots of things. And they also had, let's just say, 100 different buckets. And we're like, well, wait, we know the one bucket has all the keys to the kingdom. It has, like, if that bucket was violated, then it's game over, it's awful, it's really, really bad. And one of their coworkers said, yeah, but you'll never be able to actually figure out which one. Like, we don't have the ability to get whatever. So, like, you're gonna go and, like, you can spend the next 3 days, like, doing that. This isn't practical exploitation. And they said, hold my beer, which is a phrase I hadn't heard. And they wrote a shell script, because as consultants, you often don't have time to write more involved things, but they wrote a shell script that basically iterated through every single one of the, went through and did the same thing I was doing with those 5. It went through every single one of the roles, and from every one of the roles, it tried to do all the things, read all the buckets, and came back and basically made a pretty, well, Excel spreadsheet. And these are all our attack paths that get us there. Call it a very, 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 very poor man's bloodhound. So anyway, Hold My Beer was epic, and I still refer to it. So kube2im, why is kube2im not that strong? It's requiring every node to have a role that's capable of assuming the roles that any workload on the cluster, or at least any workload that would be on it, and usually any workload on the cluster would have, which means every single node you have is basically super over-provisioned. And the problem is, like you've got, in Kubernetes, you've got your control plane nodes, which are kind of better protected. You're not running, there's nowhere near as much ability to, there aren't going to be workloads. There aren't going to be things that, things that you put on there. Things that developers put on there, et cetera. That's not where the work is happening. And you've got the worker nodes that are the higher risk. So each one of those higher risks, each one of those worker nodes has a lot of privilege. So that's kind of the downside of kube2im. So there's your takeaway. For us, that's meant like each time, almost nobody actually goes and says, I'm going to make a node group, and this node group will only be for these sensitive things, because outside of presentations, it's not usually the case that you have only one sensitive thing on the cluster, and you're like, okay, cool, these nodes are just for that one thing. The rest of the nodes can be for everything else. You usually are doing a lot. We'll talk about that later on. So the next thing that came along, and I'm watching my time, the next thing that came along, and this is the thing I'm going to share some zero-day in, was KIAM. So KIAM basically said, okay, we're going to stop having the worker nodes have this level of privilege. Directly. The worker nodes will not, they don't need any kind of AWS IAM role at all. Like you can assign nothing to them, you can assign a dummy role that can do no things, that's just fine. What's going to happen instead is that the control plane nodes, in most clusters there's either 1 or 3, right? Those control plane nodes will have a thing that will have a role that can transition to all the roles that might be used in the cluster. But these worker nodes, they're going to do the proxying part. They're going to take the requests that are coming in and intercept them, and then they're going to figure out what role should be given, and then they're going to ask a server, they're going to ask something on the control plane, can you please give me a token for that? And that thing on the control plane is probably going to do some good security checking of some sort and say, yes, you can have it, pass it back, and give it to the thing. So this was, you'll notice the second bullet in their README, it says, hey, look, this is going to be better, this will enhance cluster security, because the thing that's going to be doing the assume role STS work is over here on the control plane. There's very few of them, the worker nodes deprovisioned. So this should be great. Okay, well, let's see what that actually looks like. By the way, let's see what that looks like. Let's go demo first. If I'm going to make you look at stuff, okay. Again, I got to turn off the one, go to the other, and go to the next thing in my playlist. Said go to the next thing in my playlist. There we go. So this is a KIAM cluster. So in this case, we're Wanda Maximoff. We have an overly privileged container, so we're able to get to the root file system of the node. Wanda Maximoff normally in KIAM, just like in Kube2IAM, the effect is asks for what asks what's my role, and is told you have that role that can just read the Darkhold bucket, nothing else. Wanda doesn't want that. Wanda wants America Chavez's powers. So what's going to happen? So Wanda's going to say, okay, what can I do? I can't read that bucket, but remember, I've got the ability to, I've got the node's file system. So I'm going to go and I'm just running a chroot to make commands easier. You don't have to do some stuff. So I'm going to run kube control commands, and I'm going to use the kubelets. Credentials. So the kubelets credentials, remember, we'll need to be able to pull secrets for any pods that will run that are running right now on the machine, but won't be able to pull all the secrets in the cluster. The kubelet has been deprovisioned. It's being wow, give me the word. Somebody who's got English. Desupported's kind of good. Deprivileged. Deprivileged. There we go. Man. Yes. Yeah. So the kubelet's been deprivileged a lot, and maybe it should be like a little tiny bit more, as I'll show you in this. But the kubelet is going to be allowed to pull secrets for anything that's running on it, and that will end up being kind of useful to us. But it also is just able to list all those pods, and that's really helpful, and get all the information about the pods, like what ARNs are done to what. So using the kubelets privileges, Wanda sees that there is, and I've made things a little harder, there's an America Chavez pod, but that America Chavez pod is not on the same node as Wanda. So America Chavez, like gone and used taints, tolerations, and node selectors to make everything else land on the one worker node, except for America Chavez, our keys to the kingdom workload, and I've put that on the other node. So from a secrets perspective, from like our normal expectations of Kubernetes, the breakout on the one node shouldn't get us Wanda's privileges. I say should, which as a longtime consultant is that word I listen for, because either as a hacker or as somebody trying to manage a gig, it's always juicy. it's always the place where someone's not sure. So what we do real quick is Wanda's going to just get that listing of pods, get all the IAM roles that are in play, same as before. We've got that kind of list of those 4, and then that travel the multiverse one up above. And we cleared the screen, and now we're just doing that one more time. We're just going to grab that list of roles and stuff it in a file, because Wanda's going to want to be back in the container and not on the node in a sec. So we've got that list of things. We also, I'm asking you to imagine that when I showed you the IP address that belonged to America Chavez's pod, that we made note of it, that we wrote it down. So you all wrote it down, right? I forgot to. So here's Wanda's IP address, 1038.04, and here's America Chavez's IP address, 1040.03. By the way, those IP addresses, one node got 1038 for its pods, another node got 1040 for its pods. Kind of, useful, and makes some of the diagrams actually make a little more sense too. So Wanda Maximoff, who's on worker 0, wants privileges that should only be available on worker 1. Making a quick little note, Wanda's on worker 0. Type faster, recorded J. So Wanda's just going to do one more thing. Wanda's going to look for everything in Kubernetes is getting stuffed in a container, in a pod. It's kind of cool. It's totally eat your own dog food. Not everything, not the kubelet. Wanda's going to take note of where the KIAM agents are, where those proxies are. You have a KIAM agent on each worker node, and they send requests for credentials onto the KIAM server. So these KIAM agents, the one that's on Wanda's node, and so again, probably shouldn't have privilege over anything that might be on some other node. The one that's on Wanda's worker node is this one whose name ends with a 9. And Wanda's going to ask for a little information about it. So we're going to say, hey, describe this pod. Tell me about this pod. Tell me about its configuration. And what we find is, oh, there's a secret. Oh, gosh, darn it, this is not specific. All the nodes have the same secret. So these KIAM agent secrets, just a TLS key and a CA cert. I was able to pull the secret because I have the kubelet's credentials, so I can pull the secret for anything that's running on my node, but not on anything else. So we're going to grab that secret, and we're going to use it. We're going to use it to impersonate KIAM. So what I did, and I'll put the source code up with the slides, is I made a little program called impersonate KIAM that Wanda can run, and we'll do that. So I need those keys. So I have those keys from the one node, and we can kind of take a look at what they look like when you base64 decode them. And the program we wrote, it's in Go, and what we did to do this, okay, so first, simple, what does it do? You run the program, you say, hi, I'm going to run impersonate KIAM, I'm going to provide that CA cert, the key and the cert. I'm going to give one more thing that's useful for the TLS connection, which is to say what the host name is of the KIAM server. That's well known. And then I'm going to say what the IP address is of any pod in the cluster I like. And I'm going to do that. I'm just pretending to be the agent. And I send that to the KIAM server. And the KIAM server says, oh, I know that IP address. That IP address gets roll, do all the things that you shouldn't be able to do from your node. But I am not really keeping track of, I could know that you shouldn't, but I'm not actually going to bother to check. That IP address gets this role. You asked for that role, and the IP address that you say you're representing is the one that has that role, so here you go. And the game's over. That's great. You can iterate through all the IP addresses. If somehow we couldn't actually get the IP addresses that were in the pods, that'd be fine. We can just run that and basically just kind of iterate through all the IP addresses in the 10 dot space. It'll be fine. So from that, we get the same kind of thing that Hold My Beer gives you, which is, hey, copy and paste these export lines, and you will get that role. So we can go and quickly just copy, paste, and now say get caller identity, who am I? And it says, hey, dude, you are that highly privileged role that your node has no business knowing anything about. And we can use it. So I think in this one, I just list the buckets. I don't actually, and so just to keep in theme with the movie, we've got the universe, we've got the different universes that were 616s in the movie, 838s in the movie. There are like 70 more, but I didn't want to write that many. So anyway, that's our QIEM thing. Let's talk about what that was about. So what we basically found is if we could compromise one node, we can't get all the secrets from Kubernetes. They thought about that. That was really intentional. They gave us powers so we could make sure that our workloads would, that if we wanted to, if we did the work, if we were willing to kind of take the financial hit, as it were, then we wouldn't have, then a compromised node wouldn't have anything that would be, wouldn't have any Kubernetes secrets or other privileges that would belong to workloads on other nodes. But we come over to AWS, and we have our thing that was supposed to be better for security, and actually, if you think about it, it's worse. Found that a little while ago, sorry, held on to it for a little bit. The good news actually is that the project is not canceled, but it's in maintenance mode. They will make security patches, they will make other kind of patches, but they're kind of telling you should go to the next thing we're going to talk about, Ursa. So anyway, that's that. I have a little diagram for how that works, how that worked based on implementation. And I will take my friend Mike's advice and not go through every little bit of it right here with you. But I spent a lot of time working on this diagram, so I highly recommend that you download it later and look at it. But it basically tells you this is how this is supposed to work, this is how this works, and if you notice, like, the problem is that the QIEM server actually never checks to see whether the QIEM agent that's reaching out to it is actually running something that, is actually running the pod whose IP address is being asked for. This is very much like a, well, it works, so it must be, yeah, it's a security tool and it's working, so that must be good. Again, this kind of thing like, oh, you're a QIEM agent. You are logged into the system, thus you are good. Cool. Right? We've all been on those pen tests, or we've all seen those systems where it's like, authentication, no authorization. Yep, it's really fun. So anyway, I try to make that a little more obvious, like, hey, wait, the pod IP's on this node over here, or one set, the pod IP's on this node over here, and the QIEM server didn't even bother. Okay, so QIEM does have one security feature where you can like annotate the namespaces to say what roles pods in those namespaces should be able to use. But that actually doesn't matter for us at all because we're just getting all the roles that are used anywhere in the cluster, and we don't care about namespaces. It's the namespaces. We don't need no stinking namespaces thing. Okay. So anyway, so that was kind of like first gen workload identity sorted. Second gen workload identity. Are you sure this is second gen? Sorted. And that brings us over to Amazon's Ursa. So IAM roles for service accounts. And Ursa is actually kind of smarter. It's not sitting there intercepting requests to the metadata API. Actually, if you're using Ursa, it's going to work differently, but you still have to go and set up an IP tables rule to block off the metadata API, or all the things that we were dealing with already are still here. You have the nodes, you have node privileges. You have whatever roles the node would get from that API, so be careful. So what happens instead with Ursa is like, it feels like some crypto people actually got a little involved. So Ursa doesn't intercept requests. Instead what it does is at the time that you stage your pod, it says, it looks at the annotations not on your pod, but on whatever service account you've got. It's like, oh, well that service account, that Kubernetes service account has been mapped to this IAM role. It's kind of nice because lots of people are allowed to create pods but aren't allowed to create service accounts. So it's kind of, you're moving the authorization to break the system further up the responsibility stack. And so Ursa basically says, I see that you're standing up a pod and that pod has this service account. I will go and get you. I'll basically go and get you short-lived credentials and I will push them into your pod as a volume. And your pod will have that volume, which means that the node you're running on will have it. But I haven't figured out how to break the node issue. I'm not bringing you the QIEM issue here. So it's cycling just like the others. The credentials are short-lived, which is great. And it's neat. And I did not give you a super dense diagram on that. So anyway, I'm going to give you a quick little demo. The issue with Ursa is still that if you get to the node, if you get to the node's file system, if you either run an overprivileged container or get container breakout, thank you, then you can go and hoover up everything you want that's running on that node, but only what's actually running on that node right now, not what could be running on it. So it's getting worlds better. So I have a little demo, and this one is even shorter, and again, I need to remember to do this. So back to our, come on, full screen. Yeah, that's the other one. Once they tell you that your time is starting to run shorter, then you get stupider. I'm telling you, we all do it. So here we are. We're in one of the Maximov's pod. It's allowed to mount the file system. This is what you see when I've chrooted just to make it so that we're working from a given directory. We can see that there are all of these. We can see that there, for every pod that's running, there's all of the volumes. Remember, I told you we come back to volumes. There are all the volumes, all this kind of stuff that's being pushed in dynamically at runtime, at the time the pod is started, and even being modified as it runs. And what's being sent in now is these AWS IAM tokens you see. So the IAM tokens now are being provided in these volumes, which actually makes them a little harder. Like some kinds of overprivileged containers can't actually get to them so easily. If we're privileged, it's endgame privileged pods probably should never exist, but or at least be more granular than that. But we can talk about that another time. So anyway, there are these IAM tokens that are being mounted in. I'm just gonna. So what's one of Maximov going to do? Find all the things that are directories. Find the ones that say container on them. And that's simply because it gives us a really quick way for me to show you which of those long hashes maps to what container names. So we have Dr. Strange's container name, and we can find other ones. So these are just the containers running on this host, on this node, which means I don't see anything from America Chavez, which is kind of a pain in the butt if I'm Wanda. So I see these volumes, and in the volume I'm using the one that belonged to Dr. Strange because he gets the title billing, that word eponymous that took forever for me to learn. And I'm going to go into that AWS IAM token directory. I'm going to find a token, and if I take that token and throw it into a JWT decoder, I can find out oh, this thing says you have you are this, it's actually mapped to service count. It's actually a bit of a pain in the butt just to find out what role that's going to correspond to. But I can take that token, I'm going to copy it out to the root file system here, and so I can exit the chroot. And then I'm going to say, okay, what roles here are available, and look at the environment variables, and use those environment variables, and basically say, Dr. Strange, what role does he have? I need that. I need the role name. So I have to find some way to get it. This is actually getting to be harder. It's a little bit more of a pain in the butt. And so now I'm going to do that slow typing where I put in the role name, I put in the location of that token file we just used, which is in /mount token. It's available in the container because we did that kind of host path mounting. And we can do that get caller identity, and it says, yep, you got that assumed role, you've got protect timestone, you have Dr. Strange's timestone, which somehow has become even more important. I think we learned that from the Loki TV show than the damn reality stones were. Yeah, people don't watch too much TV. That's good. So what we got out of that was in Ursa, if you compromise a node, if you get access to the node's file system, if you have an overprivileged pod, if you get a container breakout, then you still do get all the AWS, you still get AWS credentials for everything on the node, but only for what's in the node. So you're having that kind of situation where you're kind of getting what you expected in terms of the way the kubelet was deprivileged, in terms of what you think you should get on a node. The blast radius is lower, ideally. So this is kind of cool. So Ursa's stronger, but I was trying to search for your takeaways besides, hey, look, I broke some stuff. Oh, I just got the, cool. I have under 5 seconds or less. Hey, go grab the slides. Everyone get your cameras out. I'm going to give you a QR code. You don't have to. Go to InGuardian's website, you can find it, and there are lots of other people that you should learn from. I've put a ton of their handles on here. Also, follow InGuardians and me on Mastodon and Twitter and stuff like that, and see you around. So, thank you.